Welcome back, everyone, towards our next set of sessions. And for this hour, I have the great pleasure to introduce, in my opinion, a very interesting session where we're going to take a deep dive into big data and natural language applications. It's my great pleasure today to introduce to you Majid Hasan, who will be presenting from Singapore today. Majid is the Chief Technology Officer at ESGenie. He's a data scientist with an economic bent, and Majid is passionate about leveraging market expectations and with alternative data and AI modeling. He's currently working on an analytics startup that promises significant gains in the accuracy of economic forecasts at a fraction of the cost of currently fundamental research and due diligence practices by reverse engineering the market's collective forward-looking expectations using bleeding-edge asset pricing models. Majid holds a PhD in finance from EDHEC Business School with over 10 years of experience in building big data products for small, medium, and large organizations. He's currently the CTO at ESGenie, where he's leading the development of an industry-leading product for unstructured ESG data processing and analysis. Majid, it's my great pleasure to welcome you for the first time to Big Data Days. It's a pleasure to have you today, and I really look forward to your presentation. The floor is yours.
All right, thank you, Jam. Thank you for the great introduction. It's my pleasure to be in this great conference, and I'm looking forward to the session. And if for the audience, if anyone has any questions in the meantime, please feel free to ping me on the chat. I'll try my best to answer all the questions as best as I can. So let's get started with the talk. So the overall, I think I'm going to talk mostly about the natural language applications for enterprise use cases, as the talk title suggests. So let's start with sort of the broader AI trends that are happening in the world right now, and mostly in the context of natural language processing. So I guess many of you would have heard about ChatGPT and OpenAI, which got a lot of attention recently. So that's one of the examples of natural language processing. But it's not just limited to ChatGPT or OpenAI. There's actually a lot of advancement that has happened in natural language processing, I would say, over the last 5 to 7 years. And broadly speaking, you could categorize these advances under natural language understanding, which is a short term for describing all the different types of AI models that can understand language in different ways. So this could be these natural language understanding models could be, for example, very general purpose models like the ChatGPT, which, you can ask it to find answers kind of based information retrieval questions. Like you can ask it about who the presidents of the United States were, over some period of time. You can also ask it to write poems, stories, etc. But you could also have more specialized models that could do one or other type of language tasks. For example, summarizing text or classifying text into some predefined set of labels, or question answering model, etc. And all of these models essentially fall within the broad umbrella of natural language understanding. And some of these models are also what we call generative language models. So, for example, ChatGPT is a basically classic example of a text generation model. And then and then also other types of generative models. For example, there is video generating models, there are image generating models, 3D shapes generating models, etc. And on top of this, there's also multimodal generative models, which basically use all the different modalities like text, vision, and images all together to be able to generate different types of things. And then on top of these models, so these generative models, be it language models, vision models, we're seeing these newer applications and interfaces that are powering the modern web now. So from, for example, ChatGPT to also other types of, so basically all of the web as we currently see it, it is shifting towards a more intuitive chat-based interface where people can, rather than having to learn the user interface, complicated user interfaces, people can now interact with applications using simple natural language descriptions of what they want to do, and the app can understand what they're trying to ask and produce the desired results. So that's kind of the context or the overall theme of the talk. And then for the rest of the talk, I think I'll go deeper into how to think about integrating natural language processing or natural language understanding for enterprise use cases. So as I was saying, so basically, let's start with kind of defining the natural language understanding. So it basically it means in the context of AI, being able to perform different types of tasks that require some sort of an understanding of the language. So the examples of these tasks could include semantic search, which is, for example, if you have some enterprise documents or even external documents, and you're trying to search for some information. Historically, majority of the search engines like Google, they used to be based on keyword matching. So they would almost literally match the keywords that you typed in your search and see whether those keywords appear in the documents, and then find the documents that contain those keywords. But with these natural language models, because they have more of a more complex and more, I would say, nuanced understanding of language, they no longer require explicit keyword matching. If you're searching for something animals, they can recognize that zoos are also related to animals, birds are also related to animals, etc. So they can find these documents that may not strictly contain the same specific word, but that are still closely related to that word. Another example is text classification. So which is, for example, if you have some set of labels, for example, let's say you have different types of documents, like you have your annual reports, your financial statements, your sustainability reports. You could use a text classification model to classify your documents into these different categories. This is also a very common use case in enterprises. For example, you could classify customer queries or customer complaints, whether it is related to some credit card related issue, whether it is related to opening a new account, or whether it is related to something else. And that then helps you direct that query to the right audience or the right department within your organization. Another example is of natural language understanding is text generation, which could be quite useful for use cases where you want to generate, perhaps, for example, legal contracts. So some of these natural language models could be used to generate specific types of documents. These could be, for example, annual reports, sustainability reports, your legal contracts, or even responses to your customer queries, etc. And then yet another category is text inference, which is more kind of like a reasoning task where you have some text, so for example, question answering, and you're trying to deduce whether something is the case. So this is also a use case that is applicable to enterprises. For example, in a setting where if you're a bank and you're trying to, you have to decide whether to approve a loan application or not. So text inference is quite useful in those situations, because what you need to do is you need to be able to read through the text and decide whether it does meet those specific requirements that you have set in your bank's policy to be able to approve the loan. So that's where you could use a text inference model to make those specific inferences on whether or not this application is worth approving. It's a similar example, which is quite close to text inference, is question answering, which you could use to find specific answers to some questions. For example, questions about let's stick to this loan application example. Who submitted this loan application example? What is the amount of loan that they are asking for? What is the duration of the loan, etc. So you could extract these specific questions without having to read through the entire document. So this is sort of the broad category of different kind of the things that you could do with natural language models that currently exist. And one of the key questions that comes up once you kind of start thinking about natural language models and implementing them into an enterprise use case is what type of models, because there's quite a diversity of models, and how to basically go about implementing which models should we use, what are the considerations involved in deciding, are all the models the same? If not, how to decide the pros and cons of different types of choices that we have. And while there's a lot of diversity in terms of the natural language models that currently exist, both in terms of their architectures, their technical capabilities, their performance in terms of their accuracy, etc. From my experience, I would say one of the key things that matters the most is whether the model is open source or it's available or it's like a commercial closed source model. And the reason that kind of matters quite a bit is because with open source, is the considerations in terms of implementation are quite different. So with commercial models, so for example, ChatGPT is a classic, well-known example of a commercial model, and there are others. The implementation in a way is much easier because it's a commercially available API. All you have to do is basically get the API key, get a subscription to the API key, and then you're pretty much good to use it. There's not a lot of complicated integration or development involved in using the model. While with open source models, typically you have to have some sort of an internal data science team, even if it's just one or two data scientists who can use the model and deploy it internally on your own cloud. However, the advantage with open source models is that you have much more flexibility and control over the model. You can retrain or fine tune the model over your internal data, and you can make it much more accurate or much more useful for your own specific use cases. While for commercial APIs, typically they're all trained by the party that is maintaining the API. So there is not necessarily a guarantee that they will be a perfectly good fit for your specific use case. So it's because of these implementation considerations that I think this is one of the key choices that an enterprise has to think about when they're looking into incorporating natural language understanding into their enterprise use cases. Let's get a little bit more into these choices between open source and closed API models. Open source models, the key benefits would be that they can be hosted or deployed within the organization. And that is also especially useful relevant in situations where the data privacy is a big issue, which, as you know, is the case for many organizations today, especially, for example, in banking, financial institutions. It is sometimes by law that certain types of data sets cannot leave the organizational boundaries. So in which case, that consideration alone largely rules out using, this kind of commercial APIs because the data must necessarily leave the organization boundaries. While with open source model, that is not the case. You can deploy the model internally within your own cloud, and the data will always stay within your organization. So that's one big advantage of the open source models. So it's good for privacy, security reasons. And then another key benefit in terms of the performance is the ability to train and fine-tune the model on your own internal enterprise data, which could make it much better than commercially available choices. After the fine-tuning, the model could perform much better on the specific use cases that you have internally. The key disadvantage, however, is obviously that it's more complex to deploy open source models because you're going to have to do that work internally. Even without the fine-tuning and training, you have to think about the kind of infrastructure, the size of the models. As the models become larger, you need their considerations regarding the size of the GPU and how many clusters do you need to be able to deploy the model so that you can run it at a larger scale, especially if you're a large enterprise. And in contrast, the commercial models or APIs, they're maintained by the specialized API companies. So for example, OpenAI, and then you can access the model through their API. So it's much less work in terms of deploying the model. You actually have to do no work for deploying the model. And in some cases, because these are commercial APIs, they're already been trained on lots of data. They're already ready to use. So the quality out of the box can be better than an open source model. So for an open source model, in order to make it better, you might have to train it some more on your internal data or fine tune it. But with commercial APIs, out of the box, their performance could be better. But then the disadvantage is that you have less flexibility in terms of making any further improvements on that quality of the model, because it's typically harder to train. You have less control over how you can, how much, to what degree or in what direction you can train or fine tune the model. And then another disadvantage, obviously, as I was saying, is that around data privacy. So if the data, or if you want to use a commercial API, the data must, the chances are the data would have to leave your organization. So this is kind of the key. So these are kind of the two key considerations, I would say. One is the data privacy, and the other being, do you need the flexibility to be able to fine tune or train the data? And maybe I'll expand a little bit more on that. And so the situation, so I think the data privacy issue is relatively clear, but how do you decide whether or not do you need to retrain or fine tune the model some more? I think that typically depends on how unique or how niche your data is. If it is something that is very specific to the industry, for example, if you're looking at some technical documents in manufacturing industry or healthcare industry, the chances are that off-the-shelf model is not going to know that jargon, the technical jargon and nuances and abbreviations. So in those situations, typically the benefits of fine-tuning or retraining the model on the specific data set are quite sizable. So that's one easy way to decide whether you should go with a commercial API, off-the-shelf model, or whether you should invest in retraining or fine-tuning the model for those specific data sets. But if your use case is something which is fairly generic data in the sense that if it's like if it's not particularly specific to your organization or any specific industry, if it is something like a novel, or if you just, for example, it's like a customer open and kind of generic customer question, the chances are an off-the-shelf model is as good as a fine-tune. So now let's have a little. So now let me again deliver into how do you leverage natural language understanding for enterprises, especially in terms of how do we think about the enterprise use cases. So I would think so. Basically, I think as a starting point, the starting point should always be centered around some use case, a clear use case. In order to decide whether there is a need or whether there is a good fit for a natural language model to be employed for the benefit of the enterprise. So so start with a use case that kind of has that kind of involves some kind of language understanding or a reading, and then break it down into smaller language related tasks. And then, so before we jump, so I guess what I'm trying to say here is that before we jump into incorporating any natural language model, the first thing to do is to basically really think through whether the natural language model, what is the use case that for which we're trying to use it, and how specifically is a natural language model going to add value? Does it even make sense to add a natural language, to add some kind of AI capability into that use case? And that depends on you being kind of very specific and disciplined about what are the different steps that are involved in the use case. Which of those steps can be automated using a natural language model effectively? And what would be the benefit? Would it be the cost savings? Would it be the additional revenue potential? Or would it be something else? So quantify those kind of specific benefits that could come from incorporating different types of language models or different types of language understanding capabilities into your use case, and then allows you to kind of at least get a rough sense of the possible ROI that you could get by using natural language understanding for for that specific use case. And that then gives you a sense of whether it is worth trying to investing time and effort into incorporating natural language understanding into your use cases. Because from personal experience, what I've seen is what happens many times is like sometimes organizations or people see a trend happening and they think, oh, this is great, and we should integrate it. But then they start implementing it before doing all of this kind of ROI calculation. And then what happens is later on you realize that actually integrating a technology, especially AI or cutting edge AI, is actually quite a costly and time consuming process. And if you haven't fully thought through what the costs are, what the benefits are, what happens quite often is that later on you put in a lot of effort and time and energy into deploying these AI models internally, and only to realize that actually we cannot sustain it. We don't have enough benefit to be able to justify it, and then the project doesn't really go anywhere. So that ends up being quite a waste. So I'll discuss some case studies to basically make it more kind of concrete about what are some of the good examples where you could think about including natural language understanding. So for example, one example could be, so these are examples that I've seen from my personal experience. So a climate fund building an internal search engine to track internal data. So this use case is kind of related to semantic search capabilities that you could do with language models. So what happens in this case, for example, in case of a climate fund, they receive a lot of grant applications from these climate-friendly projects around the world. And the climate fund needs to decide whether or not to approve each of those funding applications, and which funding applications are kind of more. So basically rank those funding applications and then make a decision on. And what that process entails. So if you follow the previous step-by-step guide, what you can see in this use case is that there is clearly a lot of language-related tasks involved. So in the usual workflow, what would happen is that the fund would receive all these applications, and then some analyst would manually read through those documents, identify, categorize different types of funding proposals into different categories, that this is a renewable, this is a solar farm project, this is a wind farm project, this is some hydro project, this is some other type of renewable energy project, etc. And then there would be a specialized analyst that would read each category of those documents. So for example, all the solar power plant related applications, and then rank them by some set of considerations. For example, how much investment is needed for this project, how much solar energy it is going to produce, what is the cost of energy production per unit of investment, what is the amount of CO2 emissions that will be saved by each project, etc., etc. So the first task is, which is, ranking and classifying, as you can imagine, that can be automated using, for example, a text classification model. So that is something that can be done using natural language understanding. So that is so good. So we have identified one step of the process that can be used, that can be automated using the NLU, natural language understanding, can be utilized. The second step, which is classification, which is basically identifying, extracting the specific information or the details about each project. That sort of thing could also be handled using, for example, a question answering model. You could write down a predefined set of questions that you run on each one of those grant applications to extract the specific informations. So that's yet another step that can be automated. And the third step would be kind of ranking those projects. Once you've identified the key, extracted the key information, you could kind of do, it's kind of like a text inference task. You could ask a model, you could use the model to decide which project or which grant application promises the most CO2 emissions per unit of investment. So that also can be, so there you can use some kind of a text inference model. So there are at least 3 steps in this workflow where you could use the natural language understanding to basically automate your process, which could, save you a considerable time in terms of the manual cost of processing or reading through those documents. And yet another example, again from financial industry, would be a financial advisory company that is using language models to summarize industry trends, risks, and opportunities. So this is, so in this case, if you think about it without using LLMs, what would happen is some analysts or consultants in the financial advisory company would have to, manually search the web, look through the industry trends or look through the news talking about industry trends, risks and opportunities, and then write short summaries or create short presentations to be discussed and shared internally that then they can use to basically create advisory for companies in that industry or sector. What are the kind of latest opportunities for them? What are the risks that they need to be concerned about? What are the emerging regulatory trends that they need to be cautious about, etc. So in this case, again, if we use the step-by-step approach, we can see that there is at least this text summarization task, which we could perhaps automate using natural language models. Once we have searched the web, we could pass the data to a language model and ask it to write short summaries about different types of industry trends, risks, opportunities, etc. Another thing, we could also use natural language models to, for example, do semantic search on the relevant information. So once, let's say, if we have a news API that is sourcing, allows us to source a lot of different news about the relevant industries, we could use a language model to search the most relevant news related to the different types of industry trends or risks that we are interested in, that we can then summarize. Yet another use case in this for language models would be to, for example, so broadly speaking, could be a semantic search to identify the relevant news, and another to summarize those relevant news into neat presentations. Yet another example could be an agri-tech company that using AI to assess its suppliers. So this is more of like, as you can see, the final step of this process is some kind of a text inference problem. So what you could do is, so basically in these use cases, the way it could work is if you're getting a lot of documents from your suppliers and you're trying to screen your suppliers, for example, in terms of their commitment to various sustainability initiatives, in terms of their alignment to your commitments, you could use a language model to extract the relevant information from their documents and make inferences. So your language model takes in your considerations and then looks through your supplier's information to identify where there is a match, where there is a mismatch. And a similar use case could be applied for a supply chain company that wants to classify incoming regulatory updates and classify them into different types of regulatory changes so that the relevant team can be updated about these upcoming regulatory changes so that they can prepare themselves. So this use case, you can see it's a fairly clear cut. It has a fairly clear cut focus on text classification. So you could use the text classification model to streamline this sort of use case. And finally, as I was talking about earlier, you could utilize a text classification model or a text generation model to, for example, automate customer support. So you could be done in two ways. So you could have a language model that classifies customer queries into different types of categories, and then you pass it to a specialized customer service representative for that topic, and that answers the query. Or you could just train a language model to be able to answer the user's question directly based on your internal data. So you teach the model about different types of problems and how to best answer them. And then the model directly interacts with the user's query and gives them an answer. So now let me, I guess, get a little bit more in depth into one of these use cases. So I'll go through the climate fund example. In this case, the climate fund receives funding applications from green projects and needs to evaluate these applications to assess the most promising projects. And as I described just now, the first thing we need to do is to basically break down the overall use case into specific language-related tasks so we can identify where there is scope for incorporating a language model and what are the possible benefits. So in this case, the relevant language task would be semantic search to find the relevant documents and to find the relevant information related to, for example, emissions avoided, benefits to women, etc. Another possible use of language models would be to summarize the text. So, for example, if the same project talks about emissions avoided in multiple different places or across multiple different documents, we could use a language model to synthesize and summarize that information into one neat paragraph. Yet another example would be to use a language inference model to make specific assessments. For example, is it the case that the emissions avoided by this project are more than 1,000 tons? Or is it the case that this project is creating more than 10,000 new jobs for women, etc.? And then finally, once we have made this assessment, we could use a language model to write a short summary about perhaps ranking the different projects, comparing the strengths and weaknesses of different projects. And the benefits of these replacing the current workflow with the use of language models would depend critically on what the current pain points are. So in this case, for example, the current pain points would be, for example, that it takes too long to read through the documents and human labor is costly and the reading through the document is not the most valuable use of the analyst time. So that would be the kind of the core pain point or problem that the use of language models could solve. And then I think another important thing is that it's also there's also another kind of side benefit in using technology or language models, which is that if an employee leaves, a whole bunch of the expertise typically leaves with them. While if you're using a language model, whatever training or whatever learning the model has done over the years, it will stay within the organization. It can become better over time, and it can allow you to transfer knowledge from one employee to the new incoming employees, because they can then use the language model as a bit of a guide to educate themselves about what has historically been done, what the projects funded, what were the rationales for them, etc. So it speeds up the onboarding or the training for the new employees. So based on these considerations, we can kind of begin to think about what the ROI would be. We have identified what are the key areas where we can use the language model. We have identified the current pain points or problem statements. And so we have, all we now need to do is identify, if we remove these pain points, how many of these pain points we can remove using the language models, and what would be kind of the ROI from that. So the way to think about that could be to, we know that reading through the document to identify relevant information takes time. So if we replace that with an AI model, the immediate benefit is going to be the time saving and the cost saving from the analyst, the time for the analyst time. And that cost saving is going to be roughly the time to read one document times the number of documents there are to read. So that allows you to kind of put some sort of a dollar figure on what is the value add, what is the possible value add of adding a language model into that part of the workflow. And then the second part would be to writing kind of synthesized summaries to basically make assessments on the projects. And that again would be proportional with the manual. In the current workflow, the cost of it would be proportional to time to generate one document or one summary times the number of these summaries to write. And then one other benefit that perhaps is somewhat underappreciated is sometimes is incorporating these newer technologies. They also can save you cost and effort in terms of maintaining legacy databases or document stores, which are not always as easy to use or as effective. So when you replace so when you utilize a language model, for example, the language model can store a lot of the information internally. So you no longer necessarily need to maintain all the legacy databases. And so there could be like a tech benefits in terms of moving to a more more efficient ways of doing things. And yet another benefit, as I was saying, would be in terms of training of new employees. Or retaining the knowledge that has been learned over the years, without and not having to worry about losing that knowledge if a few of your analysts leave the organization. So now that we have a sense of our use case, our problems, and possible value add, we can kind of decide. We're at a stage where we can decide, what is how do we go about implementing. So let's say we have done the previous exercise and we realize based on the cost to reading these documents, it makes sense for us to incorporate language models. That it will save us significant amount of time, effort, and the benefits. Basically, there is an ROI. So once we know that there is an ROI, then the question is, okay, how do we go about implementing, or what is the cost? So the previous step, I guess, we've only talked about the benefits from the costs or the benefits from incorporating a model. The next thing would be to understand what are the costs of incorporating these different types of models that are going to replace this manual work. So in this case, the cost again would depend on your choice, primarily whether you're using a commercial API or you're using an open source model. If you're using a commercial API, the cost would be, the case of commercial APIs, obviously, it would depend on what specifically is the business model of the API that we're using. But let's say, for the sake of argument, that it's going to cost us $30,000 per year to be able to replace all of that manual reading and summarizing of that data using the API. And then we can say, and then if we use, like, let's say an open source model, for open source model, we know that, let's say the data is somewhere specialized and we know that we will need some kind of internal training before the open source model is capable of handling handling those tasks sufficiently well. So for internal open source models, it's generally the case that you will need at least one or two data scientists. And let's say we currently do not have any. So then you need to have it at least cover the salaries of these data scientists. And that would maybe cost you at least $100K USD. And then on top of it, the model needs to be deployed on some GPU. And that would, let's say, cost you another $10,000 per year. And then on top of it, the model training, for any additional training, you will need to prepare some training data set. And then you will need to run the training, which could be time consuming depending on the size of the model. And that could, let's say, cost you another $30K in one time fee. So overall, in this case, as you can see, after these kind of considerations, that using a commercial API makes much more sense because we only pay $30,000 per year, while for open source models, the upfront cost seems a lot higher. So at least at the beginning, it seems reasonable to start with a commercial API, see how it works. If it works well, and we see that there is, and if see how the performance is, and then if we have some gaps in the performance and we feel the need to improve the models, we could always switch to an open source model that we can fine tune or train on our own data. So based on these considerations, both the costs and benefits of NLU using natural language models in our workflow, we can now finally kind of quantify our ROI. We have the cost of reading cost of manually reading the documents and cost of using the API. We can say that it would roughly lead to so these are kind of made up numbers that it would, but they're not completely made up numbers. I think they're actually informed from an actual case study. They are, what we've seen is like you could get up to 3x reduction in cost of manual reading. You could get up to 5x improvement in the speed of processing of information. So that's another benefit. So even if it costs the same, if you can get that information processed relatively quickly, you can make more decisions, you can process more documents, you can process more funding proposals, you can basically do more business in the same amount of time. So that has an impact on your revenue. And then it could also get you up to 2 times reduction in the cost of data management system, because a lot of your data is now handled, a lot of your data management is now handled by the model that you have deployed. And then on top of it, so I would also like to mention that so while these quantifiable ROIs are important in the sense that they're important for you, for an organization to be really clear that yes, there is a use case, and to get that project approved and have it sustain and have the budget allocated and have it moving through the different approval layers within the organization. There are also non-tangible benefits that may be difficult to quantify but could be quite important. So for example, one benefit that we generally see with sort of integrating natural language models is that it improves the usability of the data. Because with the traditional data systems, the users have to learn SQL or some other complicated programming languages to be able to just interact and manipulate the data. And that limits a lot of the internal users or internal employees' ability to actually do anything meaningful with the data if they're not familiar with, if they're not super, experts in Excel or SQL or some other programming language. While with natural language models, it becomes much easier or much more convenient for any user to engage with the data. So there's that benefit in terms of it improves the data-driven culture within the organization and the employees' engagement with the data, which could have whole host of side benefits in terms of the employee engagement or employee efficiency, productivity, etc. So these also ideally the organization should have think about and kind of try to incorporate them into the ROI. And so as I was saying, so this is informed. This case study was informed by an actual case study. So and then obviously, so there's always a good side, but then there's also with any new technology, there are also the risks and challenges. So the key challenges in this kind of a case study that we noticed were that the AI models have this tendency to what we call hallucinate. What that means is that sometimes, for example, if you're using a model to do question answers, sometimes the model will generate answers that were not actually in the text. So if you, for example, asking a model, so you could also see that in, for example, ChatGPT, if you, for example, ask it sometimes a question about some author or some president of the United States, it might give you an answer that has nothing to do with that person. So that's quite a natural feature of the way that the language models are currently trained and implemented. So that is something you always have to, if your use case requires accurate information, that's something you always have to be cautious of and typically have some sort of a layer of manual inspection to make sure that your model is either sufficiently trained to be able to produce accurate answers, or if the model is not sufficiently trained, then you have an analyst just go through it and then flag any answer that's misleading. And so yet another issue typically tends to be for technical or companies or industry-specific jargon that off-the-shelf models do not understand. So these could be, for example, examples of acronyms or abbreviations. So companies use abbreviations to denote, to describe different things, which models do not understand, or they confuse it with something else. Another example is sometimes things that have a specific technical meaning within the organization. For example, what does it mean for the let's say in the case of this climate fund, what does it mean for a project to have to have a sufficient commitment to renewable energy? That could have a specific definition within the context of the organization that the model by default would know. So either you need to train the model or it would make errors if asked a question that depends on that sort of understanding. And yet another issue we found, sort of a more technical issue, was integrating these language models with the existing data stack. So that's also kind of an important point I would like to highlight, because what happens is, like, when you think about AI models, it's not just about how good the model is. It's also about how is your current data stack is. How is the model going to communicate or interact with your existing data? If your existing data is stored in a way that it's difficult for the model or the API to interact with it, then you're not going to get any real benefit out of the model. So you also have to think not just about the technology that you need to bring in, but also the technology that you currently have and how compatible the two are. And you might actually find that the best way forward is not so much to jump on the new, bringing the new AI models, but first to think about your existing data stack and whether and to change the existing data stack so that it becomes easier for you to try out different types of AI models. Because the ROI of that investment in your existing technology stack or database stack could be much higher than basically investing in making an AI model work with your legacy databases or technology stack. So to sum up this kind of a use case, the key benefits that we've found from this case study were that they're both, first of all, tangible and intangible benefits. The tangible benefits in case of natural language understanding, and especially for this use case, this sort of use case, typically revolve around cost cutting. So language models, they remove a lot of the manual work in terms of reading, summarizing, annotating, or classifying the text, and that's a clear that offers a clear ROI. Somewhat indirect benefits can sometimes come from employee engagement with the data, as well as from improvements or having to do less of a maintenance of your legacy databases as more of your data gets moved to the language models. Key challenges tend to revolve around the model's hallucination, which is important for the use cases that impact on high degree of factual accuracy. And the model's inability to understand some key terms, key company-specific or industry-specific terms. So thank you for your time. So that's all I have for my presentation. I'm very happy to have take any questions if you have.
Thank you, Majid, for this wonderful presentation. I personally have to say that I learned a lot in the process. I didn't know a lot around this, and I think this is a great example of how you could use this on a very practical basis. I think I'm joined by a lot of others because I saw quite a number of questions coming in. I'm starting with a question that came in quite early in the chat already, and there was a question from Jean-Paul Karangwa, if I'm pronouncing it correctly. And his question is, for commercial APIs, what's your advice to ensure interoperability and avoid vendor lock-in issues?
Yeah, so that is a great question. So that typically always is an issue. So my broad answer would be that the best way to avoid a lock-in is to not rely overly, is to have a think about your tech stack from the beginning. So so my advice would be, under no circumstances should you devise your roadmap in such a way that you're overly dependent on one commercial API. You should always you should always set up things in such a way that you can change. You try different APIs from the get-go to be able to do the same task. In general, if you use the model off the shelf, it is the case that they're not directly interchangeable, but with some sort of additional work around it, you can always. So, for example, if you allow me to use a bit more technical language, so what you could always do is you could always write your own wrapper functions in your programming languages. Let's say you're using Python, that basically add another layer of processing on top of the response that you get from the commercial API. So what you then do is you can have different APIs in the background, but then on top of it, you have your own wrappers, so that at the end of the day, the response that you get is always standardized. So it doesn't matter. You can always switch from one API to another without affecting your downstream tasks. And I think that is really important, because otherwise the models, AI models are not like your regular software. Even if one model is currently the best, it's working better than all the other choices, there is no guarantee that it will continue to do so. The models get retrained, and the retraining changes their behavior. And even if it improves their behavior overall, there's no guarantee that it will improve their behavior for the specific use case that you're using it for. And if it then turns out to become a a suboptimal model for that use case, you might very well have to switch to another model.
Good. I think that's some great advice in terms of looking at it more from a holistic perspective in just instead of just a specific point solution. Great. We still have time for some other questions. Let me project the next one on the screen. The next question is from Wayne. Wayne is saying, this seems like a useful case study that I can propose to my organization, but in terms of the natural language understanding that don't understand internal company jargon, what would be the challenge in training the model to understand a better fit for my organizational purpose?
So for that question, I think this is also a great question. I think for the perspective of training models on your internal data, the key challenge tends to be typically having the training data, because as once you start trying to train the data, you realize that the model needs the data in a specific format, and the training data needs to be good. And the model is not going to help you generate the training data. So that work is still quite manual and quite time consuming. And that's where, and the quality of the model is going to depend almost entirely on the quality of the training data. So you're going to need to have tools internally in place to be able to train the data. First of all, you're going to need to have your data in a place where you can basically collect enough data in your organization without having to go through, a whole bunch of layers of approvals and having to worry about, where the data actually is, which is often the case. People try to start creating training data, and then they realize we actually don't know where the training data is, like where the data is, because some of the data was stored in a database that we haven't used in the last 5 years, and now we don't know how to access that anymore. So there's a whole bunch of issues like that. So you have to be, so that's what I was saying. So I think before you start integrating AI models, I think it's generally helpful to think about your current data stack and see what kind of improvements you can make in your existing databases that will, in the longer run, help you utilize AI better. Because it's not just going to use AI models once and then discard it. That's just going to be pointless. So if you're going to use AI, it has to be part of the overall organizational strategy, which includes your existing databases and other types of data solutions that are going to be interacting with the AI systems and model training.
As a follow-up question from my side, does that mean that with the model that you've created, it's always going to be based upon the enterprise data? So it's first up to the enterprise to make sure that the data quality and curation and data stewardship so that it's actually trusted data. Can I summarize it like that?
Yes, exactly. I think that's quite right. So what I mean is, like, once you try to make a model useful and applicable, you're going to have to productionize it, which means that you're not going to be able to on ad hoc basis add training data. You're going to have like a streamlined data pipeline which ingests data from your a data lake or data warehouse or some other data storage solution, feeds it into the model on a regular basis so that the model can update itself, and that model then gets used by the users. So if the pipeline is not in place, and the pipeline requires more than just the choice of the specific model that you're using, commercial or open source, it requires that entire data stack, your databases, and how they're going to interact with the AI model. And so that's as important as the choice of the model or the or anything else.
Perfect. Good. Then I have one last question. I know there's quite a lot of questions coming in, but we only have time for one more. And this question is asking, you spoke about natural language understanding is making it easier for the end user. Can you give some examples of how easy it can be?
So I would say that the simplest example, like the simplest it can make it is sort of like a natural language query engine, sort of like a Google, where a user can just type a query and the language model can help identify the most relevant answers and bring it to them, or like a ChatGPT kind of solution. Because the reason, but that can be quite a lot simpler than, for example, traditional systems, because as you know, many of the traditional systems, the data has to be queried using SQL, which is not always something that a new employee necessarily knows, especially if the queries are complex, in which case you depend on some kind of an IT or tech person to be able to run the queries and give you data. So the employee who is going to use the data has very little control or direct control or ability to be able to slice and dice or query the data in different ways to be able to answer their questions.
Good. Thank you so much, Majid. This was really a very interesting, in-depth, and a very understandable session. So I really personally like this a lot. Thanks for your time in contributing towards Big Data Days and sharing your knowledge and expertise with us. That's what this whole conference is about. It's been really a pleasure to host you today.
My pleasure, Jan. Thank you for inviting me.
Very good. So on the next hour, we will have in track number 1, another very interesting speaker who is not going to cover natural language processing and understanding, but is going to switch towards data literacy, especially within project management. So completely different topic. Note that on the other track, we still have the workshop going on, so the practical workshop, in case you're interested in joining that. And for those of you who would like to go into the next session, and there we're going to listen to Marcus in around 10 minutes from now. I will see all of you back in 10 minutes when we start our next track. Thanks, everyone.